might make into linear models that aren't linear to begin with. So if you look at fishing line, the strength that it can handle and the length that's sold, right? Typically the higher the strength, or there's some kind of relationship, because the problem is the stronger the line, the thicker it is, so then less you can put on the reel. So maybe there's a relationship there between the strength and the length sold, basically. So if you want 35-pound line, what's the predicted amount of length that's sold, basically? Okay, and the second one being baseball players. So there's the year and then the salary in millions, basically. Okay, we want to make a prediction for the year 2000 and 2025. What is their predicted salary for those years? Okay, so if we go to my spreadsheet here, there's the fishing one here. So again, what I did was I took the original data and I graphed it, and that's clearly not linear, and I got 61% for the R squared, right, which is not great. Okay, and I did the standard deviations for X and Y, got the R, the means, which calculated the A and the B, which gives me this equation here. Okay, so can I make an equation here, chart? Oh, I got to turn on the trend line. That's the problem. I forgot. So if I do equations, trend line, there's equations and values. I think that's where we go. And we want the R squared. There we go. Okay. So there's our equation in R squared. Does that match up? Yes, it does. Doesn't match up. So not a great R squared value. Clearly not linear. So then I used my A and B, right? And, right, A plus BX, right? Figured out my predicted. And my residual is the observed, right, which is my Y. Mine is predicted. And I did a scatter plot. You notice this is a non-linear pattern, right? So if you notice in your notes here, let's go to the notes, that I put a regression, right? I put this little file right here, scatter plot reexpression summary. Okay, and what you'll notice in here, okay, is one person's perspective. Oops, why is there a pop-up? I don't need an AI assistant, thank you. Okay, let's blow this up a little. Okay, let's say it curves one way, curves the other way, right? Or curves this way going up, right? You should consider the quadratic exponential power for this one, reciprocal exponential log for this one, logarithmic square root of power for this one, basically. If that is the original graph, that's what you should, so these are the ones that are in that power table, essentially. Okay, these are the different models you should, is that for sure? No, those are the ones you should first consider, basically. Okay. If you're looking at the residuals, right, if they look like these, right, so if it looks like this, you should consider logarithmic. If it looks like a dip like this, use the power one. Right, this one's bottom more to the left, this one's more centered, this one's more to the right. If it's more to the right, use exponential reciprocal. If it's more centered, use quadratic or power, right? If you kind of have these little arc things right here, use square root of power, right? And then you have the arc going this way, just maybe logarithmic, just the x log it. Or if it's shifted to the right, kind of this one, just maybe use the regular logarithmic also, right? Okay. So there's some suggestions, basically, and here's some examples. Right? If this is the original model, this is the residual. They used the log of x to make it straighten out, because it wasn't straight to begin with, and they did straighten it out, right? And same thing with this one. This is the original model, the original scatter plot. This is the residual plot. They used logarithmic, right? And this expression, exponential. So this is clearly not going to fit a linear to begin with. This is the residual plot, and they re-expression, basically. Okay, so if we look at what I have, oops, this is my residual plot. and this is my scatter plot. Okay, not great either way, right? So this is kind of shifted to the right, maybe, I'm thinking. So if I look at my little sheet here, let's go back. This one's to the right, so perhaps exponential and reciprocal, right? And if I look back at the original exponential, it's also saying doing power, right? Is that the, yeah. Yeah, because if I look back at my original, let's see, where is it? Here's my residual plot, which is on the right, right? And this one is kind of curved this way. So if I look back here, it's kind of curved that way. No, wait, curving down? Curving down. So we could try a few different things, right? So r-squared value is not always the best thing to look at. You can't just take the highest r-squared value. It was terrible to begin with, and these are the other r-squared values, right? So using that little chart there, the negative reciprocal looks like a good one, right? So if I do that, I get this r-squared value, and I get these predicted residuals, and I look at the scatter plot. Oh, even though it's a really good r-squared value, I still have a pattern saying nonlinear, okay? Which means even though this is good, right, it's still nonlinear, so I didn't actually make it into a nonlinear model, right? Okay. Well, this is the best one, right, which is basically taking the log of x and the log of y, right? So if I do this one, right, log of x and log of y, oh, now I have a pattern, right? But you're like, well, it's not the same pattern. Does that matter? Well, let's go here. So I graphed log of x and log of y, and I did the residual. Yeah, it's 0.98, but if you kind of look, it's kind of a wave, isn't it? Right? Which means it's still nonlinear. So should I use this to make predictions? Let's go back here. So it's saying, right, 35 pounds a line, make a prediction. I probably shouldn't use it because it still kind of looks nonlinear. So even though I did many re-expressions here, kind of using that guide, trying to figure out what the best one is, right? Again, don't necessarily go by the r-squared because you have to also check the residual plots to make sure they're nonlinear. It still failed, so I shouldn't use that model. Okay, let's look at the baseball one. So the baseball one, okay, has a good r-squared value. You're like, ah, look at that. And I do a graph, right? So here's my graph over here. And it looks kind of linear, doesn't it? Right? Then I do my residual plot. And what you notice is, ooh, I got a pattern here, don't I? Like a horseshoe. That means it's not non-linear, which means I should do a re-expression, right? So it's a U, kind of, right? Maybe it's centered. And it's kind of going up to the right, but if you kind of look at it, it's kind of dipping, isn't it? So it's kind of doing like this, correct? So if I look at my thing, what does that tell me I should probably do? So it's kind of dipping. I don't know. It's dipping up. It's going to be quadratic, exponential, or power, right? And if I look at the residual, I think that's the residual there. Maybe just a power one, which is the log of both. Okay, so it gave me some suggestions there as to what I should do. So if I go back to my calculations here, what did I do? Okay, so it looks like I did this one like it said. Okay, I got 0.93. All right, but I do that, and the problem is I still kind of have a pattern there, don't I? So still not linear. Yeah, I got better. I went from 84 to 94, so I got better, but the residual is still kind of saying there's a pattern there, right? Then I went to these ones, which is this one here is logging just the y, and this one here is logging both. And what you'll notice is when I do these residuals and predicted, both of these are now kind of all over the place, right? Which means I probably made a linear model. And I look at that one, and look at that, right? Now it is kind of linear, isn't it? It looks better than the original. Kind of lost that pattern. So I would say these two are good, which means this one here is the log of both. This one here is just the log of the y. So this is the, let's move this over. So this is, did I hide it? Oh, there it is, I hit it. So this is just logging the y, and this is just logging that basically. Okay, so let's do a prediction basically. So long story short, with this one we can make a prediction. So it wants to know the year 2000 and the year 2025. Oh, wait a minute. 2025 is well beyond the data set. That's extrapolation. I cannot do that. But I can do 2000. Okay, let's do that. So let's go to our data set here. So equals A plus B times, and I think I used whole years here. I did. 2000. Okay, but if I do that, that's the log of y. So to get rid of the log, I need to do equals 10 to the power of this, right, to get rid of the log. And that is 15.2, right, and these are millions of dollars, right? So year 2000 is about in there. That makes sense, between 15 and 17. Millions of dollars, right? All right, so let's go to here. So this is equal to A plus B times the log of 2000, right? Because I logged both. And then I have equals 10 to the power of this to get rid of this log here, right? So I'm working it backwards to the original data, because right now, this is not the original data, right? It's when I logged it, right? So this right here, okay, is when I logged it. Actually, is this right? Yeah, because I just logged the y, basically. And this is when I logged both. No, I guess not. Oh yeah, it's the reciprocal one, right? Oh yeah, it's the reciprocal one. Okay, so I logged one of them. So, long story short. Okay, so this is millions of dollars. Okay, so pretty close, right? Pretty close, which both of these are one. So either one of those would be fine. This one would not be fine because it doesn't seem to follow a linear model at this point either, right? It still is too far off. It seems to be a pattern residual. So, long story short, what do I want? Even though it might look linear, right, we can make improvements because this is clearly saying it's a pattern, right? So find the one where it improves and there is no pattern anymore, right? You don't have the hetero and you don't have a pattern, right? Okay. All right, so let's look at a shutter one real quick. So the shutter one I made up. It's a so you have the shutter and the f-stop on a old-fashioned camera, right? So you look at this one, you're like, that's pretty good linear, 95%, but there's kind of a curve in there, isn't there, right? So you're like, well, I should check the residuals. I check the residuals, you go, ooh, that's definitely a curve, right? Okay, so I'll go through, I'll look at this curve going this way, and I'll look at this one going this way, and I'll look at the various ones it probably should be. And the chart says it's probably the y squared, or it's the log of x, or it's the log of both, right? Those are the ones that the chart says it's probably going to be, which have better r squared values. Well, except for this one, it really doesn't. But you're like, oh, okay, well, we'll try them out. So I'll do my predicted residual. So the first one here, right? Oh, seems to have a pattern still, but going the other way. And I tried the next one. Oh, it seems to have a pattern going the other way. And then this one, now it becomes hetero, right? It's not spread out, then it becomes spread out. So looks like this one I can also. So you might not be able to get rid of the pattern, or you might run into a hetero situation. Perhaps this one's good. I don't know. Maybe it's hetero, maybe it's not. It seems like it is. So I would probably, on the shutter one, probably stay away from it also, basically. Okay? So long story short, don't be doing any predictions and assume that you can make a expression unless you found one that has a good r-squared value, perhaps better than what you were started with, right? And you can actually look at the residuals and make sure that it's actually no model, right? So here, if it's a residual looks like an S, right? It's basically kind of sinusoidal. There's nothing you can do. I guarantee there's nothing you can do, right? And if it's just, this is probably meaning there's no model whatsoever. So meaning even because it's so low to begin with, even changing the model won't matter. So even though, yeah, it looks like I can maybe flatten this out, it's so bad to begin with, there's no real point in doing it, right? So there's probably no model whatsoever. You cannot make it linear, right? You can try to make it linear, but it just stays nonlinear the whole time. Or you try a bunch of things and you found a couple that work, right? Then you can use those basically. So now you've made it linear. Okay?